Hey students, welcome back. This is our Tide class number 5 and should be our last on Tide. So after this, we're going to move on to our water safety, and you're going to be receiving books like this and like this in your packet. So we're going to have, let's just say, different exercises like dot to dot, coloring, and other things that are going to be able to help you and also keep your family safe. So that's one of the reasons we're going to be doing this. Okay, now, just to kind of sum up a little bit of what we did last time and tell you a little bit more, we're going to also be having, after this, after the class we're going to have on water safety, we're going to be having our last series of marine science classes on sharks. And that's going to be kind of a cool one. We're going to have some videos of actually sharks getting caught and research that's being done. And that's going to involve me and also some other classes that we're going to have that are going to have videos. Now, also, just to make you aware, we're going to be looking at some of the homework and other things that you're going to be doing and kind of watching on what you're doing. And for those students that are really getting their homework done and everything, we're going to have a little drawing and we're going to have some prizes, kind of awards for students that are really paying attention and doing a good job, which makes sense. Because if you're not really paying attention and you're not really doing the lessons, maybe you shouldn't be getting any rewards, right? So, okay, well, hopefully everyone's going to be doing their homework and listening up and paying attention. So now, what we're doing now is we've already, on our last class, we've talked about the forces that are involved in the universe, and some have been gravity and some have been centrifugal force. Okay, so we're going to be talking a little bit more about those. And the last class, if you remember, we also launched a rocket and we put the rocket into orbit. Okay, so let's talk a little bit more now about a couple of other forces.
Hey kids, this is gravity. If you don't know what gravity is, then you might want to see it. Are two examples of centrifugal force. The first example is you could take what I have is just a little bit of ribbon and some electrical wire, and if you spin it, you can see that the electrical tape goes everywhere around like this, but it does not touch my fingers. And that is one way, that is one example of centrifugal force. The next example, you can see the coin right there, and if I spin the tire slowly, you can see the coin stays on there. If I go a little bit faster, it's moving a little bit, but if I go like this, the coin flings off. So those are two examples of centrifugal force.
Okay, so as we said, when we launch the rocket, we have to remember the two forces that are most important to us right now is the centrifugal force, which kept the rocket from crashing into the Earth. It kept it away. And then the gravity that held it towards the Earth. And as we said, they both pull on each other, actually, when we think about it. Now, all the forces in our universe are deal with gravity and centrifugal force. All of the planets are being held toward the sun because the sun has the most pull in our universe because it's the biggest. So the sun's pulling on all of the planets, and centrifugal force is keeping all of the planets away from the sun and also keeping them all balanced in each other. All the moons that we have on Jupiter, all of the moon that's around the Earth, everything's being held through gravity and centrifugal force. Now, to give you an idea again, okay, students, so now we talked about launching a rocket. Now, this is the International Space Station. And as we are talking right now and you're watching this, the International Space Station is orbiting our Earth. And there's people up there living. And we are sending rockets up to give it food and oxygen and other things that it needs. But this is in orbit. And again, the thing that's holding it towards the Earth is what? You're right, it's gravity. Gravity's holding it to the Earth. And what's stopping it from crashing into the Earth? And just, smashing up? Well, the centrifugal force. So as it's spinning around the Earth, it's being held in place. Now, right now, there's about 8,000 satellites orbiting the Earth, all at the same time. They've all been launched and they're all in orbit. And the other thing you might want to do, which is kind of a cool thing, is at night, after the sun starts to set, if you go out and look at the sky away from the ocean, in other words, we want to look at towards the east, away from the ocean towards the Sierra Mountains. If we look up in the sky, you can see satellites going around the Earth. The sun reflects on the satellites and you can see them all going around the Earth and being held there, okay? Now, if we think about it, if we are, if the satellites are in orbit around us, okay, so if we think about it, if the satellites and the space station are being held to the Earth by gravity, okay? And as we said before, the Earth is pulling on the moon and the moon is pulling on the Earth. We're pulling on each other. The moon's gravity is pulling on the Earth. So here's a question for you. Is it pulling on us? If you went outside your house right now and stood and the moon came over your head, would it be pulling on you? I'm saying yes. I'm saying if it pulls on the Earth and we're on the Earth, it would pull on us. Now, here's another one for you. If you went and put a scale out in your front yard and you stood on the scale and the moon came over, would it pull on you and would you weigh less? I'm saying yeah. You'd weigh less. Now, you know how much less? A little tiny bit less, but you'd weigh less because the moon pulls on us and we're on the Earth. Now, let's just say it's not going to pull us up into space because, again, gravity is going to hold us down, okay? But think about it. When the astronauts were on the moon and there was less gravity, they could jump really high. They could jump right over the top of your house because there's less gravity because the moon is smaller. But now, let's say you went down to the beach, and let's just say you lived near Moss Landing or a beach on the Pacific Ocean that you went next to, okay? And the moon came over your head. Would it pull on the water? Yes, it would, because the water is fluid. It's not actually part of the Earth. It's floating around on top of the Earth. So if the moon came over and you were standing there, all of a sudden it would pull the water up. You'd have to move back. You'd have to move away from the water because the moon would pull it right up by your feet. And then if the moon went away and started to go down, it would pull the water away from the shore. So the moon is what really creates the tides, okay? Because when the moon pulls on the water, it pulls it towards us. And when it goes away from us, it will pull us down, okay? So with that in mind,
gravity. Here's the Earth rotating on its axis every 24 hours. We'll now draw the Earth as a diagram with its surrounding layer of ocean. And to the right is the silvery moon. Everything is attracted to everything else in the universe with the force of gravity. So the moon is attracted to the Earth, and the Earth is equally attracted to the moon. Notice that the two force arrows are the same length, showing that gravitational attractions are of equal strength. But we're only interested in the force on the Earth here. The moon pulls on the ocean closest to it and makes it bulge outwards. When the Earth rotates, the sea level is higher at this point in its rotation, causing a high tide.
let's end it there. Okay, students, so as we saw, the gravity of the moon pulling on our ocean is what makes the high tide. Now, what happens is because the moon is here and it kind of pulls, as it pulls, may I have a pencil, please? Thank you so much. As it pulls on the earth, okay, it kind of squeezes the water. So it's a high tide on this side of the earth, and it's also a high tide on this side of the earth. Now, what happens is each day there's one high tide is higher than the other high tide. And that's because the moon's effect is so strong when it pulls on this part of the water is higher than this high tide. So that's why we have 2 high tides a day. And we have, again, 2 low tides every day. And again, they're 6 hours apart. So that kind of sums up what we have going on there as far as the tides go. So hopefully you'll realize that the moon affects the tide. And when the moon's over your head at the beach, it's going to be a really high tide. Okay, now our next class is going to be on water safety. So I look forward to seeing you then. And thanks a lot.